In this section, we'll look at some more editing tools that relate to digitizing, and it will be useful to you as you begin to work more with editing and digitizing processes. First of all, transforms. This converts data from one coordinate system to another, from digitizer or scanned units to real-world coordinates. It's used to shift data within a coordinate system, for example, from feet to meters. Oftentimes you might find that there's a mismatch between data that's been scanned or digitized manually and the coordinate system that you're working in. So transform processes will allow you to then line that data up, properly match it, and go from there. In rubber sheeting is a method used to deal with geometric distortions that commonly occur in source maps. Those distortions may be introduced by imperfect registration and map compilation. This could have multiple different sources. It could go back to bad GPS data that's collected. It could go back to mistakes in manual digitizing. And there could be other factors as well, such as a lack of geodetic control in the source data or poorly transformed data from one datum to another or one coordinate system to another. So there are lots of different potential causes. So rubber sheeting corrects the flaws through geometric adjustment of coordinates. In other words, you're attempting to align features between two different feature classes where one is registered properly on the geographic or projected coordinate system. And rubber sheeting basically calculates and takes into account interpolation of likely positions by comparing the locations of those two features in two different layers. Edge matching aligns features along the edge of one layer to the features of an adjoining layer. A layer with less accurate features is adjusted while the adjoining layer is used as the control. Attribute transfer is typically used to copy attributes from a less accurate layer to a more accurate one. In other words, you're putting the data onto a new target layer. Spatial adjustments are often done for CAD drawings. Typically, CAD drawings of buildings do not have geographic coordinates. And so when you're given a CAD drawing, it might be positioned in lots of different ways, and the features of the building may or may not match your target data. So one of the tasks you'll do in the lab is that you will do some spatial adjustment in order to match a building at a university in Pittsburgh. So here's the drawing of Hamburg Hall, the building at Carnegie Mellon University, and then here's the same building on an ortho photo. So in this case, if you notice, it spatially can be matched using displacement links. Displacement links essentially allow you to, what the black lines there are showing you, in fact, allow you to match known coordinates on the building, such as corners, in order to shrink it and align it with a target layer. And the result, as you can see then, can be edited from there to become the most accurate possible drawing of that building. But you're going from CAD drawing this in this way that's not geographically referenced to a geographically referenced feature class. In the next section, we'll look at digitizing and creating new features in ArcMap. So in order to do this, you'll see in the lab manual, you'll be creating new feature classes in ArcCatalog. You create a new feature class by navigating to the desired location, a folder, or more typically a geodatabase. And then you right-click and go to New, and you create a new feature class as either a point, a line, or a polygon. You'll need to add the spatial reference information that matches your target data, and then add new fields as needed. In ArcMap, you then load a base map or an image that's geographically referenced. You're going to use that as your base map, and then you'll digitize features from there. You add your feature class and start the editing session. You digitize the feature through editing and then save it when you're done. So for example, this is a base map that shows Point Park in Pittsburgh. Vector features or raster images may be used, and then you're going to be adding features. In this case, we're using a raster image as our base map. We then start an editing session. When you do that, a Create Features window will come open, or you can open it yourself under Editing Windows. For example, this tells us that we're going to be digitizing trees along a street. Those are points. And so then you would digitize and add your points to represent the locations of those trees. When you're finished with the digitizing session, then you would stop editing and save your edits. And then edit the attribute data as needed. Again, you'll need to start a new edit session in order to edit the attribute data. And in that attribute data, you may want to add details about the trees. You can also add attribute information while digitizing on screen, so you can do it all at one time if you choose to do it that way. So there are several different ways that you can enter the attribute data, and you can go back and edit it later on, but the key is to get used to using the edit features within ArcGIS, which a lot of you probably haven't had much experience with yet, but you'll get more experience as the class goes along. And that concludes the lecture sections on Unit 3 on digitizing.